Hello and welcome. It's great to be part of Esri 2020 virtual event. My name is Phil McGavro and I'm the Director of International Business for Cityworks. For the next 20 minutes or so, my team will be talking about some really powerful stuff related to the Internet of Things. But first, I need to provide a quick disclaimer that the information provided here is intended for informational purposes only and may not be incorporated into any contract. The reason I chose this topic to talk about today is because as a result of steady population growth, aging infrastructure, and the realities of climate change, all pose immense challenges on the health and sustainability of our infrastructure. Now more than ever, it's increasingly important to manage what we do and how we do it on a day-to-day basis. Whether you're managing a network of water, electric, sewer, roads, or any other infrastructure type, these assets should and could be maintained in a responsible, efficient, and effective way to help create a sustainable environment for all our populations. In the 2019 Australian infrastructure audit, they mentioned that the infrastructure in Australia's 4 largest cities is failing to keep pace with rapid population growth, particularly on the urban fringe. And the quality of infrastructure services for people living in small towns and remote rural communities do not meet the standards that Australians expect. The audit also highlights that the changing and growing demand and mounting maintenance backlog means that a new wave of reform and investment is needed to ensure a sustainable economy and a quality of life over the next 15 years. By 2034, Australia's population is projected to grow by over 23%, thus adding to our infrastructure demand, all while the existing infrastructure struggles under these maintenance backlogs. We need to evolve. We need to be progressive, not just anticipating demand, but maintaining what we have in an efficient and effective way. Having real-time operational awareness of our infrastructure to detect problems before they occur will help us accomplish this to manage our valuable assets. I'm joined by Becky Tamaszewski, Executive Vice President of Vision and Product Engineering at Cityworks, and Robbie Knobber, Product Manager at Trimble. They'll show us how Cityworks and ArcGIS combined with the Turnbull Unity remote monitoring software and the Trimble Telog wireless sensors are transforming how we maintain essential services and protect community health.
So let's start with the remote monitoring portfolio. So our Telog IoT recorders, recording telemetry units or RTUs, have been proven in the field for many years. They support a multitude of water and wastewater asset performance monitoring to reduce leakage and non-revenue water and better manage pressure on the water distribution system, also to proactively detect and minimize sewer overflows and environmental impacts on the collection systems. The RTUs are rugged, they're wireless, battery-powered devices that are easy to install and cost-effective to maintain. They provide a secure, accurate, timely, and reliable data with near real-time alarms for anomaly detection. So on the water supply and distribution side, the Telog RTUs and sensors support monitoring flow using our insertion flow meter, pressure and pressure impulses or water hammers, water level on tanks or reservoirs, and leakage using our acoustic leak detection sensors. And on the wastewater side, on the collection system, the Telog RTUs and sensors support monitoring rainfall, open channel flow level, and sewer overflows, including also lift stations. The RTUs can also connect to various types of sensors that have either digital or analog inputs, or we can connect with sensors over industry standard protocols, including Modbus or I2C and others as well. So all of the data that's collected from Trimble Telog family of IoT recorders and sensors feeds into the Trimble Unity remote monitoring software. It's a GIS-centric cloud and mobile software offering advanced workflows, analysis, and reporting tools to proactively monitor, measure, and improve asset performance, and detect anomalies to preempt issues that can cause infrastructure damage, disruption of service, and environmental impact. The software empowers your organization to respond quickly and effectively, reducing operations costs, improving regulatory compliance, and protecting public health and safety. And you can quickly gain asset performance visibility and awareness in a few steps. So starting with using the Trimble Unity mobile application to install the Telog recorders in the field, then set up the sampling and recording intervals and alarming thresholds to detect any operational anomalies, and how these events are raised. Then be able to activate any performance KPIs you want to update in your GIS against assets that you are monitoring. So that will allow you to support GIS-based analysis and risk of failure assessment efforts that we'll show later on. And finally, use the built-in reporting and analysis tools available in Trimble Unity remote monitoring to monitor your distribution and collection systems. So now I will hand it back to Becky to present how our solution enables intelligent asset management by combining Trimble Unity remote monitoring with Telog and Cityworks and GIS. Becky?
Thank you, Rami. And so we wanted to give a little overview of Cityworks, just for those attendees who might not be familiar with the application. And so Cityworks is a web GIS platform. We have essentially two sides of the solution: our AMS, Asset Management Work Management System, and our permitting, land management, and licensing solution. These can be used independently or cohesively for an overall application and workflow across organizations. And then we expand this functionality with other plugins that are across our portfolio to provide tools that start to get into resource allocation with workload, budgeting tools, payment management, public-facing portal to initiate and manage the permitting process and applications, analytics that are available through ArcGIS Insights and can immediately be hydrated with your application data from Cityworks. As well, we offer a storeroom tool for inventory and material management, iOS and Android native apps for field mobility, and then our application Respond, which is what we're actually highlighting as part of the solution in combination with operational insights to start to develop asset and risk strategies for the infrastructure. And so with that, I'm going to actually dive into those core activities within Cityworks Respond. And those really come down to, let me see, am I a little bit too far? Let's get back. And those come down to our core activities for public requests, which in this case is actually the initiation of those activities within a workflow. And in terms of the integration that we're showing today, this is starting with the IoT sensor data that's coming in, alerting us of an issue in the system. And from there, we're able to go ahead with Unity and generate the inspection for Cityworks, which allows us to take Respond out into the field and capture those observations, determine asset condition and performance, and identify what follow-up activities are needed. Based off of the observations that are being captured, the work orders generated in the system, this allows us to start to track more detailed data, getting into project management, contract management, the use of resources such as equipment, labor, and material across a work activity. And then as all this historical data is being generated in the system over the course of days, weeks, months, years for many of our clients, we're able to start to do reporting and analytics and bringing that information together within a spatial context in the GIS to give a greater in-depth view and help organizations with operational decision-making. And so in terms of how we're processing that information and Respond, from here, those users are able to go ahead and let's just go back one. Those users are able to go ahead and process, as I mentioned, those inspections. So Respond is an application that's responsive and dynamic to their field devices. It allows them to be, standing over the valve out in the field, a hydrant and main, and view the spatial information in the same context. Their GIS data from Esri is presented. It's dynamic, showing real-time updates to the GIS and repositioning based off the location of the work activity. As they're going through and populating and performing inspections or interacting with activities in Cityworks, they have that context for other work activities that are taking place, real-time dashboards to give them more information, and the ability to see their GIS data and query and interact with it in real time to help assist with that information process in the field. And then as those activities are completed, it allows organizations to start to take that data into Cityworks operational insights. And from here, we can go ahead and develop a risk strategy or an asset strategy in the application. This is coming from an organization's GIS. From here, they're able to view in real time their GIS attributes, prioritize which fields start to go into play for their probability of failure calculations, consequence of failure, and the resulting business risk exposure. As well, as part of this integration that we're developing, we're able to also leverage the KPIs and metrics that are being established in Unity in relation to the asset performance and use that as well to start to review and query and define what the asset strategy looks like to determine the risk and prioritization of the infrastructure. And from there, we're able to start to perform analytics, to start to come into the system and take that information that's being captured from Cityworks, Unity, and Ops Dashboard to go through the process of looking at how that information can be visualized for data sharing and to provide analytics across the organization. These are tools that can be shared out in terms of reporting processes and updating, but also allowing those organizations to view in real time as information is being captured and displayed spatially across both Operations Dashboard and ArcGIS Insights. And so to show you what this actually looks like, Rami is going to go ahead and kick off our demonstration.
Thanks, Becky. Let me get control here. All right, so we'll show you an example using pressure monitoring to kind of walk you through the workflow and show you the capabilities of this solution. So what you're looking at here is the login screen for the Trimble Unity remote monitoring web application. I will go ahead and log in by entering my username and password. And once I log in, the application will show me the list of all the monitoring sites and location of these sites on the GIS map. I can also see any open work orders or inspections managed in Cityworks, all from within the same application. So first thing, I want to look at the overall system health by opening the system health dashboard, which shows the various interactive widgets that summarize the health of the assets we are monitoring and the health of the Telog RTUs. Looking at the pressure impulse widget at the bottom here, we can see some critical impulses detected recently by the pressure sensors. So if we drill down to view the details, you could see that the Outpost Drive site had 17 severe impulses within that time period. And I want to analyze and see what's going on there. So let me bring up the impulse and pressure data for that site. And you can see a lot of pressure fluctuations during the last 3-day time window of this report, with impulses tagged on the graph, color-coded by severity. Looking at this statistical summary, it shows a wide range in pressure within the time frame of this report. And the pressure impulse list shows a summary including pressure range for each of the detected impulses, some having pressure ranges of over 40 psi. So we can further analyze these pressure impulses and load the high-resolution sub-second pressure data to view the signature impulses that are being detected and look at those signatures. These impulses, if gone unnoticed, can cause water main breaks and infrastructure damage, especially in high-risk areas. So if we go back to the dashboard and we go look at the location of that site on the map, You can see this site is located in a pressure zone that had many historic leaks, as presented here via the heat map along the pipelines. There seems to be also an open work order that's managed in Cityworks. If we click on that, it indicates there is a water main leak that's being scheduled in the area as well. So we'll close that work order. And one of the values of the solution we're presenting here is the ability to create integrated views of data from Trimble Unity, GIS, and Cityworks that provide real-time insights across your organization. So if I go back to the dashboard and I can show you an example of an ArcGIS dashboard we've created that shows the GIS map, it shows the pressure impulse and alarm summaries from Trimble Unity, and the dashboard also brings in leak history and customer complaints reported and managed in Cityworks. We can filter the high pressure complaints and view the results on the map as well by clicking on that complaint from a customer, all from within the same view that can be shared across your organization. So now that we identified there's clearly a pressure issue in this pressure zone that needs to be investigated, we'll go back to the map and we'll zoom into the location there of the pressure regulating valve that's feeding this pressure zone. As you can see here, clicking on that valve will show the valve details from the GIS, and I can select it and create a Cityworks inspection to send out to field technicians to investigate. We'll go ahead and select the priority and add some recommendations and comments. And once that's done, we'll also choose the Cityworks PRV inspection template that's configured in Cityworks for the PRVs. And once I do that, you could see the PRV is tagged on that inspection already in Unity, and then creating that inspection will automatically send that to Cityworks and then progress it through the workflow. So before I hand it to Becky to show you how the inspection is progressed in Cityworks, I'd like to show you a couple of other key features that populate data in GIS and Cityworks. So let's go ahead and close this inspection that we just created, and we'll go back to the outpost monitoring site that reported these pressure impulses. And once I load this site, you could see the site details on the right-hand panel. I have activated pre-canned KPIs that on this site, which includes daily average, min, max pressures, and impulse count by severity. We can configure those KPIs to update the GIS data for analysis and risk of failure assessments. So in this example, the daily average pressure values is set up to update on the highlighted water main segments here showing on the map in the GIS. And once that data is available in the GIS, then you could access these KPIs and be able to use them for analysis. Another feature related to alarms is the ability to set up alarming thresholds and ability to raise events, Cityworks events, when these alarms are detected. So here I'm going to the RTU settings for that site, where I can update these settings. And some of the things I can update is the call schedules, sampling and recording intervals, and alarming thresholds. So I will update the settings to raise a low pressure alarm when the pressure drops below 30 psi and lasts more than 10 seconds. And when the alarm is raised, I want members of the central operations group to receive this alarm via email or text, depending on what's configured, and also raise a leak detection event in Cityworks on the pressure zone polygon in the GIS. So this event is configured to automatically create a Cityworks leak detection investigation that will be raised as soon as the alarm is triggered. So when I update this, now we'll go ahead and update these settings, and when the unit detects these alarming conditions, they will raise those events. So now I will hand it back to Becky to show us how this inspection we created on the PRV is progressed through its workflow and how we can use the data to create risk of failure assessment.
Thank you, Rami.
Becky.
And so what we're actually looking at here is Cityworks Response, the application I just briefly described. And you'll notice as well that operations dashboard that Rami was showing, we're able to embed that within Cityworks Respond. Users have the ability here to start to filter and interact with the dashboard to identify certain types of customer complaints. But then we can also go ahead and search for that inspection that Rami just previously created in Unity. We're able to open that up and view it in the context of our GIS. Initially viewing here the information in a full view with all of our infrastructure information, other related activities that are showing nearby to give more context for items that are being viewed in the distribution system. And we're also able to zoom in and start to dive in more to the details of the attributes that are present there. We can see the location of that valve, where this, the inspection has been created, the symbology for that inspection. And we're able to now go ahead and, as I mentioned, view information side by side in the same context within Respond. Being able to view our inspection activity information in the same context as our GIS, and then for full visualization of the inspection fields, just missing the map. And from here, we can go ahead and start to populate some of our observations, going through and completing that information, and then going through and identifying information related to the condition of that asset and the performance that we're noticing here in the field. And from here, based off of these observations and the determined resolution to complete and repair this item, we're able to go ahead and start to initiate additional work activities. So I'll go ahead and complete these fields and start to populate some of the date and timestamp data for our record keeping reporting processes. Go through and mark that yes, a work order is needed, but the work order has now, this inspection has now been completed out in the field. And once I go ahead and save this activity, based off of logic that's been generated in Cityworks to identify criteria for generation of certain types of follow-up work orders based off of this inspection results, we're able to now see that a work order has already been generated in the system automatically. I can view that work order. I can see if there were other related activities that were part of this inspection that could be seen. From here, I can open that work order and go through and start to process more information as well. So if we were to say we immediately went out to the field and we wanted to view again where that information was located, I can see again that same context for where the inspection was created, the PRV associated to it, and other infrastructure within that area, and heat maps showing clusters of activity that are coming in from Unity. We can report that there was a replacement of that valve diaphragm, population of who completed the work with the date and timestamps. And if needed, we could also start to dive into more information here with tracking of the equipment, labor, and material that was consumed as part of this work order activity. And as I mentioned, there's also flexibility for tracking of project data, additional contracts, and allocating this back to certain budgets that have already been established within the organization. So from here, once I go ahead and save this work order and the activity is completed, we can move on to the next step in the process. And this is where all of that information, all the activity information that's being generated, the data from those KPIs that Unity is tracking and compiling and writing to the GIS, as well as the organization's GIS information and that attribute data comes into play here in operational insights in Cityworks. From here, we're able to start to go through the process to establish the priorities for our probability of failure. And you can see here that we're pulling directly from the GIS. So these are the GIS attributes for the domains in this region. We're able to go through and prioritize which attributes have the highest priority in terms of looking at the calculations here for the probability of failure. It's a similar process that we'll be showing next for the consequence of failure, but this is also where those KPIs that are being brought in from Unity, such as the number of leaks against certain mains, those are being able to be used and prioritized as well and consumed for this calculation and establishment of the probability of failure and consequence of failure going into the calculation of the business risk as well. So you can see here as I go through this process, I can go through and complete as more attributes are being added to really flesh out the calculation here for the probability of failure. And this is part of the flexibility with the application as well, given that it's coming off of GIS data for your organization. It's all real-time and accurate data. And it gives organizations the flexibility to decide what fields for their infrastructure are relevant for their goals in relation to their asset strategy program. And so next, I'm going to go through and start to complete the same process again for the consequence of failure. And so I'm looking here at different priorities, moving away from more so the attributes of the pipe for the material characteristics, such as number of leaks, material and diameter, and start to moving into more of those consequences in terms of the pipelining type, in terms of accessing and the consequences, in terms of if there's a failure, what are the consequences in terms of providing that type of repair. Also the system zone, and additional information can be brought in here as well, such as soil type. As those calculations are completed, we can view that information here, and you can see as I'm filtering through the process here in ArcGIS Insights, as that data has been imported, I can start to filter down and look at the areas where the highest pipe leaks have taken place against material and BRE score, identify where those are spatially, and see the breakdown of the BRE score in relation to various makeups of the mains within our geography here. And this allows me to have that full view of that information that's coming in from Unity with our IoT and sensor data, Cityworks with our historical work activities, and then also pulling in that information from the GIS and the attributes of our infrastructure and providing it all in a spatial context to give that visualization for analytics for organizations, as we mentioned, to really start to help support that decision-making within operations. And so with that, I'm going to turn things back over to Rami.
Thanks, Becky. So to recap, the integration between these powerful products we presented today create a unique and comprehensive digital platform with real-time asset intelligence, workflows, and analytics that help you gain better insights into asset performance, shifting your focus from reactive to proactive asset management practices. And with that, you can reduce infrastructure failures and repair costs, improve customer service and response, and use this real-time performance data to support business risk assessment and probability of failure assessment to help you make informed decisions when prioritizing repair activities in high-risk areas and to ease your regulatory compliance efforts.
Thanks, Becky and Rami, for this great overview. And thank you all for joining us. For further information, please visit us at cityworks.com or feel free to contact me directly at my email, pmagavro@cityworks.com. Thank you all and be well.